Let's try to understand what are orbitals and quantum numbers. See, the orbitals in an atom is any orbital. There may be many orbitals in an atom. So each orbital is distinguished by three quantum three quantum numbers. The orbitals are any orbital. There are many orbitals. Orbitals means the place, the space around the nucleus of an atom where there is a maximum probability of finding an electron. So then there are many orbitals, right? So this is one orbital, this is another orbital, and then there's another orbital. But any orbital is distinguished by three any orbital is distinguished by its size, its shape, its orientation on X, on a Y or Z, anywhere in space, its orientation, how it is maintained. Is it straight? Is it slanted? Is it horizontally or is it vertically? How the orbitals are orientation. So an orbital will have a distinguished size, it will have a distinguished shape, then orientation. Now these are given by these are described by different quantum numbers. The principal quantum numbers denoted by small n. The shape is corresponds to azimuthal quantum number denoted by small l, and the orientation of the orbital is described by magnetic quantum number. It's a number, right? Magnetic quantum number, with the symbol ml. L, small l, it means its value depends on azimuthal quantum number L. So an orbital is distinguished by their size, shape, and orientation. Size corresponds to principal quantum number, the shape corresponds to azimuthal quantum number L, and orientation corresponds to the magnetic quantum number ML. But these three quantum numbers, for any orbital, there will be a specific principal quantum number, an azimuthal quantum number, and a magnetic quantum number. Next, so what is principal quantum number? As we have as I've told you, principal quantum number n, it will have only positive integers, either 1, 2, or 3, and it also determines, and it's denoted by 1, 2, 3, 4, 5, 6, 7. It will go on like that. The first I did. So what does the principal quantum number do? It determines the size. Not only size, it determines the energy of the orbital. An electron will be staying in an orbital. If it stays in a particular orbital, the size of the orbital will be told by the principal quantum numbers. For example, if the size 1, it will be this big. Size 2, it will be this big. So as the principal quantum number increases, the size of the orbital increases. The space around around the nucleus increases. So the principal quantum number, it determines the size, and it not only size, it determines the energy of the orbitals. Say if it is 1, it is having the least energy. If it is in the second, if the principal quantum number is 2, it means it has more energy. The orbital has more energy. And if the principal quantum number is 3, it means the orbital has again more energy than that. The principal quantum number, it also identifies a shell. We say shell, first shell, the second shell, the third shell. Not only it gives us the size and energy of the orbital, it also tells in which shell that orbital is. So it is identified in shell. And shells are denoted by some capital letters. For example, the first shell, 1, is denoted by K, and second shell denoted by L, then third shell M, and it goes like that: K, L, M, N, O, P, Q, that. Now, so is with the increasing quantum number, principal quantum number, the energy, the size of the orbital will increase, the energy of the orbital will increase. Okay. The principal quantum number. Okay, there's one more thing that I wanted to add. For species like hydrogen or helium and or lithium, 2 positive, or beryllium 3 positive. These are species that we have learned earlier having, although the number of protons are 1, 2, 3, and 4 respectively, the number of electrons are only 1. See here, 1 electron has been removed from here. There were 3 electrons, 2 electrons have been removed. There were 4 electrons, 3 electrons have been removed. That means this species got only 1 electron, one electron system, or one species with only 1 electron. For this, the principal quantum number also determines not only the size, the energy level. Huh. Now having, if say if there is one, means for them the principal for multi-electron atom or multi-electron system having more than 1 electron, the energy of an orbital is determined not only by the principal quantum number but many things quantum. But in case of this species, the energy of an orbital is determined only by the principal quantum number. As the principal quantum number increases, but the size and the energy of the orbital increases. Okay, there's one more thing that principal quantum number signifies. It signifies the number of allowed orbitals. So in the first shell, how many orbitals will be there? In the second shell, how many orbitals will be there? It's given by the n square. For example, for the first shell, n square, 1 square is 1. So there will be only one orbital. And for a second shell, 2 square of 2 is 4. There will be 4 shells. Sorry, there will be 4 orbitals. And we have learned earlier that each orbital will have only can accommodate only 2 electrons. And in third shell, how many orbitals will be there in the third shell? It's given 3 squares 9, so there will be 9 orbitals possible in the third shell. So number of orbitals in a particular shell is given by n square. Here it will be, for the first shell there will be 1 orbital. In the second shell there will be 4 possible orbitals. In the third shell there will be 9 possible orbitals. Hope you have understood.